Let's continue to talk about how we define a pointer variable and how to assign the value to the pointer variable. Like earlier we say, if we want to define a pointer variable, we define the data type with the asterisk. So that means the variable is a pointer. So this pointer only can refer to, because this one is an int pointer. So this pointer variable only can refer to an int variable. Then if we define a num is an int variable equal to 25, we just assume this num variable actually is located at a memory address is 4800. So remember the 0x just means we will start for the hexadecimal number. So then I don't want to put too many numbers. We just say, for example, the address is 4800. So this num at locate is 4800 and this 4 byte holding the 25 value. So how to refer to this memory address? That we need a pointer, because a pointer variable only holding a memory address. So that's why here we want to get the memory address for the num variable. So that's why I need to have the asterisk, the ampersand associated with this int variable. So then they will return the memory address back. So this memory address will be assigned to the pointer variable. So the same thing you see here, when we define a pointer variable, right? We have the pointer variable here. So the pointer variable actually holding the address. So how many bytes for the pointer variable actually is according to the system you are running. So the pointer variable actually they have their how many size they were allocated as well. So the size for the pointer variable is according to your computer system. So did you remember sometimes we say you run on 32-bit environment or 64-bit environment? So this means your memory address, how big it is. So 32-bit means 4 bytes. So that's why for the 32-bit environment, pointer variable actually holding 4 bytes. So 64-bit environment, the pointer variable actually holding the 8 bytes. So that's the difference. So that really depends on your computer system. So here we just say, for example, this one, if we run on 32-bit environment, so then here your pointer variable will be in 4 bytes. So then they will holding the address. So that's the meaning for the pointer variable. The pointer variable, always you have your asterisk associated with the data type variable you want to refer to. So that's why here, if we want to refer to the int variable, we're using the int pointer. So for example, right, if you have a double variable, our pointer becomes double pointer. But here, let me show you only for the int data type first. So then your pointer, you see, after you define your pointer variable, this pointer variable, if we want to assign the value, you need to assign the memory address. So that's why we do the ampersand for the num. Num is an int variable. So those memory address will be holding in the pointer variable. So you can either assign the memory address to the pointer variable, or sometimes if you define your pointer, but you didn't know your location, the variable you want to refer to, we can simply assign to 0. So this 0 actually means the no pointer. I don't refer to any memory location. So initialize pointer variable, you can do either the keyword no pointer, the no PTR. So this no PTR actually is the keyword introduced, represent in C++. You can either do like this, okay, or just equal to 0. They are all the same. So when you have your pointer, your int pointer variable called PTR, then if you assign equal to the no PTR or equal to 0, they are all the same. They just mean I initialize and define the pointer variable but I just assigned the default value equal to 0. I didn't assign any value yet. So easier to see, we see a program like this. So that's why here the same thing, we define our value variable int x equal to 25. So I declare my PTR variable as an int pointer. So I can either equal to 0 or equal to the null pointer. So you can see if you assign equal to a null pointer in your IDE, they will show they are a keyword. So then we can assign the pointer location, pointer value equal to the %x. So this one actually we will refer to the PTR for the memory location for x. So then you can see if you only want to see out x, they will get the value. But if you want to see out PTR, you will display their memory address value. So that's here. So that's our example for the pointer variable. Of course, please pause your video and download your example too. We can run on our IDE to see the result as well. So that's why here is our chapter 9 example 2. We have our variable, int variable defined. Then we have our PTR is the int pointer. That's a null pointer. So then here you can see PTR, we assign the value is the memory location for x. So then when we want to display the value for the x or the PTR, by default the x, they will display with the value for x. Then the PTR, they will have the memory location. So that's why you can see x equal to 25 and the address of x, or we can say the value for the PTR pointer is the memory location. Then you can see again, right, when we run the program again and again, their location will be different. Okay, so this one is for the int variable, right? So we need to be careful when we say the pointer. Actually, this asterisk keyword and operator make this variable is a pointer. So when I have the int pointer, I only can refer to the int variable. So that's why here I can have another y equal to 100. Okay, so then here you see I have the PTR. Since I have x and y, I can either refer the PTR pointer to x or I can do y. So that's why if I have the PTR refer to the memory location for y, so then now the PTR actually is the address for y. So then here, your pointer, according to your data type, you can refer to that data type variable. So now you will say, that's for the int variable, right? If I want you to have a pointer to refer to a double variable, okay, for example, I have a double variable d. So then they equal to 125.75. So now here, if you try to still using the PTR, so this PTR point to what? Yeah, point to the int. So if you try to still using the PTR to refer to the double variable, okay, so we see if they can allow us to do that. Okay, so if you do so, then you can see, right, they give you the error because they are not have the same data type. Your int, so let me show you the whole arrow. So the arrow actually show you your pointer is int data type, int pointer data type, but you try to assign to the double. So that's why when we define a pointer to refer to the variable, we need to make sure they match their data type. So that's why here, if you want to refer to a double variable, you need to create another pointer. You see, the asterisk means this new variable name is a pointer, but this pointer will refer to the double data type. So the same thing, this double data type, I can declare that and we initial to 0 first. So now afterward, right? So after you have this one, then you have a double D, right? So then here, our double D memory location, I only can using the double pointer to refer to that. So of course, here we have the value display. So then the same thing we can display. Again, the value for D is what? Okay, so the address for D again, so then they should be the new pointer variable. So that's the DPTR. So after you have the match data type to refer to your variable, so that's why here we will see the DPTR, they will refer to this variable double D. So then of course they will be in different memory location. So right, then you ask about, I have the pointer to refer to the memory address. What's that for? So what's that for? Let me show you now. Earlier we only show you the pointer holding the address, right? But also we can using this pointer variable to refer to the value of the memory address they refer to. So this one we call the indirection operator. We have the indirection operator, this asterisk. Earlier we're using the asterisk to specify the variable data type is pointer. But when you have the asterisk operator to associate with a pointer variable, then you try to access the item the pointer refer to. So that's why you can either read or write the memory location you refer to, so that variable data. So what does that mean? We see here, I have an x int variable. So I'm using my int ptr refer to x. So now you see here, before is what? Okay, so that's why we see here. One thing is earlier I forgot to tell you. If you declare your pointer, you are not only can assign equal to 0, you also can initialize the variable, your pointer variable, with the memory address. So earlier we do this one in 2 lines. We declare first, then we assign. But you also can declare your pointer variable, then right away you assign to the memory location. So be careful, you need to do the %x. So we assign the memory location for x to the int ptr, right? So earlier you need to be careful. Before we try to display the int ptr, when we without the asterisk, I try to display the value the int ptr refer to. So that will be a memory address. But now if you have your int ptr, right, you have a pointer variable associate with this dereference operator. Actually, they will access that memory location address. So let me show you in the memory location. Right, we have x located in somewhere. It's 4800. So I have the value for the x is 25. So then I assign int ptr to the memory location for the x, right? So that's why int ptr, this variable net holding the address. So that's why here you have 2 things. If you only want to see out int ptr, they will display this value. But if our pointer have the asterisk associated with that, they will using this one we call dereference. They will see this memory address, then I dereference to access this location. So that's why when you do the pointer variable dereference, they will display the value for this variable, the memory location they refer to. So that's what we call the indirect operator. So you are not only can see out the int ptr, you also can using this one to assign the value. So if you use the int ptr to assign the value 30, so then they will override this value from 25 becomes 30. So that we call your indirect operator can not only read to display the value they refer to, they also can overwrite the value that we filled.